Today, 6.1, I think I mentioned this yesterday, 6.1 is all on different ways to combine functions. So yesterday we looked at 4 different ways: addition, subtraction, multiplication, and division are 4 ways to combine functions. And then today we're looking at the 5th way to combine them, and that's through composition or composing 2 functions. So ultimately, there's kind of 2 different sets of examples we're going through. One is if your functions are given to you as ordered pairs, and then one is if you're given functions as equations. But either way, you want to be able to find the composition of functions. And you have, I believe you saw this in Algebra 1, but it would have just been introduced and not covered too in-depth. But we have done I guess, kind of application of composition. We've never talked about it using that terminology. But when we get to the last set of examples, hopefully you'll see that you have simplified expressions that are using composition before. You actually would have done that on your Chapter 5 test. You would have done problems similar to the last example we're going to do. So as it says at the top, this is just another method to combine 2 functions. So in a composition of functions, the results of one function are used to evaluate a second function. So in this box, what this is explaining, it's showing the notation you're going to see, and then I'll show you or explain to you how to actually say this. So it says, suppose f and g are functions such that the range of g, so the y values for g, is a subset of the domain or the x values of f. Then the composition function, and it's written here, it's also written down here. So it's written as f, and then I know this is light. This is just kind of an open circle written in between f and g. So it's not a dot, it's not the letter O, it's just an open circle. Some people read this as f circle g, but it can be described by, and here's 2 different ways to write it. So both of these ways, you read this as f of g of x. So the first way they have it written again is f with a circle and then g, but you would say that as f of g of x. You say the second one they give you the exact same way, f of g of x. I prefer this notation because this notation really shows that you're substituting g into f. So it's a function substituted into another function. So what this diagram is also showing, you kind of work with composition from the inside out. So here in this notation, x is first being substituted into g, and then g of x is being substituted into f. That's what this is showing. So you're starting with x, and that is being substituted into g of x. And then you take whatever y value you get from that, and that gets substituted into f. So the last one, I'm just writing over this because I know it's lighter on your sheet. But the y value from g of x then gets substituted into the function f. And you end up with f of g of x. So you're starting with an x value, and you're kind of over 2 substitutions getting your final y value. And we'll go through examples. So then what it says below before we get to the first set of examples, the composition of 2 functions may not exist, or parts of it may not exist. So if you're given 2 functions f and g, sorry about that. If you're given 2 functions f and g, then f of g of x is defined only if the range of g, so the y values of g, would be a subset of the domain of f. We'll talk about what exactly that means. And then likewise, so then you can also have g of f. So the other way to write this would be like that. So whatever the second function written is, that's the function that's being substituted into the other one. That's the insidemost function. So that's only defined if the range of f, so the y values of f, would be a subset of the domain of g. So we'll look at exactly what that means in example 1. So we have a pair of functions. They're both given as sets of ordered pairs. And it says find f of g of x and g of f of x if they exist, and then state the domain and range for each composed function. So I have some directions written out for both f of g and g of f that I'll explain further. So for f of g, first of all, I'm going to write this in the alternative way. So this means I'm substituting g of x into f. And why I'm writing it this way is this means the x values that we're starting with, since they are first getting substituted into g, we should be starting with the x values of the function g. Okay, so I'm going to look above. I see the function g is the second one listed. I'm just going to underline the 4 x values in those 4 ordered pairs. Those are the x values that we're going to be using. And so I'm going to set up, I'm going to do one at a time, but I'm going to set up 4 values that are written this way, but in place of the x here, I'm going to be substituting in the x values from g. So I'm first going to find f of g of, and the first x value from the first ordered pair is 7. So I want to find f of g of 7, or see if it exists or not, I should say. And so then what you want to do first, again, work from the inside out. So I first need to evaluate what is g of 7. So to find g of 7, I just look at the ordered pair. When the x value of g is 7, the y value is 0. So g of 7 is the number 0. So this then just becomes f of 0. So g of 7 means what's the y value for g when x is 7, and that's 0. Then, this now tells me, this is an f here, to evaluate what is f of 0. So now I have to look at the function f, and I have to see if any of those ordered pairs have an x value of 0, which the last one does, and that y value is negative 1. So this then equals negative 1. Okay, and I have 3 more of these to go through. So if you didn't quite follow that, you'll see in the next ones. It might take a couple for you to fully see where everything's coming from. So now I'm going to write this as an ordered pair. So what does this exactly tell me? I'm trying to find what ordered pairs are in the function f of g. So this tells me one of my ordered pairs has an x value. The very x value I started with was 7. So the ordered pair has an x value of 7. When x is 7, the y value is what I ended with, which was negative 1. So in the function f of g, one of the ordered pairs is 7, negative 1. Okay, and I could have at most 4 ordered pairs. Since both f and g have 4 ordered pairs, the most my f of g function will have is 4. So it might have 4, or it could have less than 4 if one of them doesn't exist, or more of them don't exist. So then I continue, I do the exact same thing, but now with the next x value for g, which is negative 1. So I'm finding f of g of negative 1. So I repeat that process. So for g, when x is negative 1, the y value is 7. So I would then write, I'm finding f of 7, so g of negative 1 is 7. And then I have to look at the function f to see, do any of those ordered pairs have an x value of 7? And the third one does. The y value is also 7, so that equals 7. So then this ordered pair has an x value of negative 1, and the y value, the very ending y value, is 7. So negative 1, 7 is another ordered pair. Okay, continue on. I have 2 more to go. Next x value is 4, so I'm finding f of g of 4. And if I look at the function g, when x is 4, the y value is 9. So g of 4 is 9, so I have f of 9. Then I look at the function f, at my ordered pairs. If any of the x value 9, the second one does. That y value is 4, so this equals 4. So then that ordered pair has an x value of 4 and a y value of 4. And the last one, I'm finding f of g of 8. So looking at the function g, when x is 8, y is 2. So g of 8 is 2. So then I have to find f of 2. And in the function f, when x is 2, it's the first ordered pair, y is 6. So that equals 6. And then that ordered pair has an x value of 8 and a y value of 6. Okay, so then here's how to write your answer, and we still also, once we write the function f of g of x, it does also ask us to find the domain and range. And that part you found domain and range from ordered pairs before, so I don't want you to just circle these and leave it. See how f and g are written as a set of ordered pairs and braces? That's how I want you to write f of g of x. So f of g of x equals, and then in braces, I'm just going to list the 4 ordered pairs. So 7, negative 1, negative 1, 7, 4, 4, and 8, 6. And then I need to find from this new function, just list the values that are in the domain and in the range. Also as a set of numbers, so in the braces, separated by commas. So I know I've kind of already said this even in this lesson already. Domain, are those the x or y values? X. So I would look at the ordered pair, the 4 ordered pairs I have now, list the x values. They don't have to be in numerical order. You just have to have them all. I'm going to write them in order. So I have 7, negative 1, 4, and 8. So negative 1, 4, 7, 8. And then range is the y values of the ordered pairs, which are negative 1, 7, 4, and 6. And that would be the answer for f of g. Okay, so I'm also going to go through g of f with you with those same functions. What are there questions so far on this one? Okay, so it's kind of knowing which numbers get put where. So then for g of f, and I don't want to move this up too far because I still want to see the functions. I'm actually going to use a different color. So g of f means I'm substituting f of x into g. So this is just an alternative way to write it. And so then what this means is x first gets substituted into f, and then that gets substituted into g. So the x values here that you should start with should be x values of f. So I'm going to underline those 4 x values in blue. So the first ordered pair for f has the x value of 2, so I'm first going to find g of f of 2. And so if I look at the ordered pair for f, when x is 2, the y value is 6. So this means that I'm finding g of 6. So then I have to look at the function g and see if any of the ordered pairs have an x value of 6, which they don't. So if that happens, this means that that value is undefined. Okay, so that's what I was saying before, is the most ordered pairs I could find would be 4, because each of them have 4. But it's possible that one or more of the ordered pairs won't exist. This one happens to not exist. Okay, it is possible that all of them will not exist, in which case the function itself is just called undefined. So that could happen. So then I just move on to the next one. The x value is 9. So I'm finding g of f of 9. So for f, when x is 9, y is 4, so that means I'm finding g of 4. And if I look at my function g, I do have an x value of 4 and the y value is 9, so that equals 9. So that ordered pair has an x value of 9 and a y value of 9. Okay, so at least one point exists. So then the next x value for f is 7, so g of f of 7. And for f, when x is 7, so is y. So this would just be g of 7. And then I look at g. The first ordered pair has an x value of 7, y coordinate is 0, so it equals 0. So that ordered pair has an x value of 7 and a y value of 0. And the last x value for f is 0, so g of f of 0. When x is 0 for f, y is negative 1, so this becomes g of negative 1. And when x is negative 1 for g, y is 7, so it equals 7. So that ordered pair, move this up now, has an x coordinate of 0 and a y coordinate of 7. There's only 3 ordered pairs for this function. So then I want to actually write out the function like I did for f of g. So g of f of x equals, as a set, the ordered pairs 9, 9, 7, 0, and 0, 7. You don't need to put the undefined, nope. So you might end up with a function, maybe only one ordered pair actually works, so it's just one ordered pair in your list. Yep. And then I list the domain and the range, and that means there's only 3 values for each. So domain, x values, I have 9, 7, and 0. And for y values, I have the same, 9, 0, and 7. Again, you don't have to write them in numerical order. I know I did, but I won't take off if you don't. Okay, so what I would like you to do, I'm going to leave this up here. I'll flip back to it actually. What I would like you to do right now, though, is if you flip onto the back, example 2 is the same type of problem. And it says, for the pair of functions, find f of g. So you don't have to find both f of g and g of f, just f of g, if it exists, and find the domain and range. So work on example 2 in your groups or on your own. I'll leave this up here in case you still need to write something down, and I'll give you a minute before I start walking around. I can check what you have. I can answer questions if you have them, and then we'll move on. Okay, I'm going to just put this up here right away. I know some of you might be finishing up, but you can check when you're there that you're getting the right ordered pairs. Everybody, at least if you weren't quite done when I walked around, if I didn't stop by you, it's because I didn't notice anything at that point that was totally off. But are there any questions? It depends on what you did. Like, oh, probably just a half. If I can still see, let you know what you're doing. Yeah, yeah. So not a whole lot, yeah. So I think, yeah, most of the mistakes I was catching, it was like you had 310 or something like that, even though you had 8. But. All right, we'll move ahead then. If you still have questions on this, just make sure you catch me before you leave. The next part, though, should be more familiar to you. We haven't talked about it this exact way, but you've done problems like this already. So I need your attention back up here, please, for the last example. So both of these, notice now f and g are given as equations. You're still finding f of g and g of f. And as you saw from the first example with the ordered pairs, f of g, g of f, they're not the same thing, so it doesn't matter which function you're substituting into the other. So, and you can write them however you want. Like I said, typically if I see this, f of g, I would write it this way, or you'll see me write it that way more often. G of f, you'll see me write this way more often. But either way is fine for you to write it. You do need to understand that they both mean the same thing. So for A, I'm going to find f of g first. We have to find both. So we'll start with f of g. So I'm going to show you a way that'll kind of tie this into what you've already done. So just as this looks, this means I'm substituting g of x into the function f. And you can see that the function g of x equals 2x minus 1. So how I'm going to write this, I'm going to replace the g of x here with 2x minus 1. So I'm finding f of 2x minus 1. Okay, now this is what I was saying on your Chapter 5 test. I had given you, I think I gave you a function p of x, and I said find p of x plus 1, or it was something like that. This is now that same type of problem. If I'm finding f of 2x minus 1, that means I look at the function f of x, and wherever I see an x, I have to replace it with the quantity 2x minus 1 and then simplify it. So how this is going to look, here's my function f. So I have 3x squared. So rather than writing x, I'm going to write it as 3 times the quantity in parentheses. I'm replacing the x with 2x minus 1 squared. Then I have minus x, and again I have to replace that x. So I have minus in place of the x, the quantity 2x minus 1, and then I have the plus 4. Okay, so that's me substituting 2x minus 1 in for all of the x's. Then I have to simplify it. So I notice simplify, before I can distribute the 3 here, I need to take care of the 2x minus 1 quantity squared. But how do I simplify that? FOIL, yes, I cannot distribute the exponent. So if it helps, rewrite 2x minus 1 quantity squared as 2x minus 1 times itself. So I'm just going to rewrite this whole thing, but I'm writing that quantity squared as the 2 parentheses so I can FOIL it. So I'll have 3 times, I need to FOIL first before I distribute the 3. So if I FOIL this, I have 2x times 2x, so 4x squared. I'm going to combine the middle terms right away. So 2x times negative 1 is a minus 2x. I'll have another minus 2x from the inside, so minus 4x when I combine them. And then negative 1 times negative 1 is positive 1. And I still am going to have to multiply all of that by 3. I'll do that in the next step. I can, here for the minus 2x minus 1, I can distribute that negative to get rid of those parentheses. So that becomes minus 2x plus 1. And then I still have the plus 4 at the end. So then I'll distribute the 3 to this trinomial here and then combine like terms. So I have 12x squared minus 12x plus 3, and then just carry down the minus 2x plus 1 plus 4. So now when I combine like terms, I end with 12x squared. I have minus 12x minus 2x, so minus 14x. And then positive 3 plus 1 plus 4 is a plus 8. And that is f of g of x. Okay, so this one, just because of the function f of x we were given, that one had more steps to simplify. Some take more steps to simplify. Some are one step, super simple to simplify. It just kind of depends on what you have and what you're trying to find. So that's f of g. I also need to find g of f for the same two functions. And you'll see here what I'm talking about, that f of g, there's more to simplify than there will be for g of f. You'll see that here. So g of f now means I'm substituting f into g. So I'm going to replace in the parentheses here what f of x actually is. So I have g of f of x is 3x squared minus x plus 4. So that means if I look at the function g, I have 2x minus 1. Where I see that x, I have to replace it with this whole quantity and then simplify. So I'll have 2 in place of x times the quantity 3x squared minus x plus 4. And then I still have the minus 1 at the end on the outside. So then all I need to do to simplify this is distribute the 2 and then combine like terms. So if I distribute the 2, I'll have 6x squared minus 2x plus 8, and then I still have minus 1 at the end. So I can combine the 8 minus 1 to get 7, so 6x squared minus 2x plus 7 is the function g of f of x. Okay, and again, I know I said this before, you can see f of g, g of f are not the same function. So you need to be careful and understand how to go about finding each one, because if I just ask you, say on a test, to find one of the two, you want to make sure you're finding the correct one. So I'm going to have you, for part B, there's two new functions, f and g. I want you to find f of g and g of f, so find both. And then when I come around, I'll not only check what you have, but I'll also pass out your assignment, which is a worksheet again. So I'm not checking it for a grade, but you'll have, or there will be problems from it on your homework quiz on Thursday. Just want to make sure you understand this first. Zach, I'll come over by you. Here, if I didn't get to check yours, here are the correct answers for part B.